Okay, in this lecture we're going to revisit the rules for exponents, but we're going to restrict ourselves to rational exponents that are not integers. Okay, so the rules are the same. Okay, so let's suppose R and S are rational in the sense that they are can be integers, of course, but they may not be integers as well. So the first one is that if I have R and I multiply by a to the s, then we simply get a to the r plus s. If I have a to the r divided by a to the s, then I get a to the r minus s. Okay, that's the quotient rule really, because that's simply a to the r over a to the s. Okay, we also have a to the negative r is going to be 1 over a to the r. We have ab to the r is going to be a to the r b to the r. We're going to have, of course, a to the r to the power of s is going to be a to the r times s. And of course, if we have a over b to the r, we get a to the r over b to the r. Okay, so let's do some examples of this. Okay, and we're going to simplify each of the following. Right, let's suppose we want to simplify 12 to the half by 12 to the 7 halves over 12 to the 3. So we end up with, of course, 12 to the a half plus 7 halves over 12 to the 3, which of course is 12 to the 8, which is 4, over 12 cubed, 8 on 2, all right, which is 4. So this gives me 12 to the 1, which is 12. Okay. All right, next, let's do part B. Let's suppose we have 100 to the 5 halves times by 16 to the negative 3 quarters. Okay, so notice we don't have the same base here. Okay, so what we're going to do with this one, of course, is we need to start looking at each one separately. So this would be 100 to the half to the power of 5 times by 16 to the quarter, negative 3, which of course will be, this will be 10 to the 5 by 2 to the negative 3. So I end up with 10,000 here over 8. Okay, which of course is 5,000 over 4, which of course is equal to 2,500 over 2, which of course is 1250. Okay, so we can break it all the way down. All right, it's part C. All right, let's suppose that we have 4z now to the 3 quarters by 5z to the 2 fifths. Now, of course, this becomes 4 by 5 is 20. Let's do the numbers first, and this will be z to the 3 quarters plus 2 fifths. So we're going to add the fractions. And, of course, to do that, we'll need a common denominator of 20. So this will be 15 plus 8 on 20. So this will be 20z to the, what have we got there, 23 on 20. Okay, part D. All right, let's suppose that we want to do something a little more complicated. And we have 5a to the 4 thirds over b to the 2/3, and this is all raised to the power of 3, and we have a to the 3 over 8 b to the 4, and that's all raised to the 1/3 power. Alright, so what are we going to do with this? Well, notice here that we have 5 cubed. If I do the exponent rules here, I get a to the 4/3 by 3, which would be 4, over b squared, because 2/3 by 3 is 2. And now we're going to have a to the 1 here, over 8 to the power of 1/3 will be 2, and this will be b to the 4/3. So I'm left with 125 on the top, a to the 5, over b to the 2 is going to be 6, so it's going to be 10/3. And there's my result. Alright, let's try, let's suppose I have x to the 2/7 by x to the 5/7 minus 5 by x to the 12/7. Now here we distribute, so this would be x to the 2/7 plus 5/7 minus 5x to the 2/7 by x to the 12/7. So I end up with x to the 7 on 7 minus 5 to the 14 on 7, which x to the 14 on 7, which of course is equal to x to the 1 minus 5x squared. Okay, now of course we may want to reverse this kind of process here, and let's suppose that we want to factor here now. So let's make this a different example. Right, let's factor. Alright, part A, let's suppose we want to factor 14 x to the -4 plus 21 x to the -3. Right, now if you look at this one here, clearly 7 is a common factor. What else is a common factor here? Well, if I take out the largest negative exponent, which is really the smallest exponent, I'd end up with a 2 here. Plus, now what do I multiply this by? Well, it'd be a 3. And how would I get an x to the -3 when I have an x to the -4? Well, I have an x to the 1. And you'll notice that when I distribute this, I get exactly this thing back, but I've gotten rid of any negative exponents here. Right, let's try another one. Let's suppose we have 18 a to the 4/3 minus 12 a to the 1/3. So again, we look for common factors in the numbers, which of course is 6. Now we look at this and say, okay, 4/3. Now if I was to take out a 4/3, or if I was to take out a 1/3, what would happen if I took out a 1/3, for example? Then we would have a to the 1/3, and I'd have a to the 1, because that would give me 4/3, minus 2. So I'd end up with 6a to the 1/3 by a minus 2, which is a good factoring form. Alright, let's try one more. Let's suppose that we have something like x minus x plus 2, say, to the negative, say, 2/5, and we have subtract an x plus 2 to the 3/5. Now, what factors am I going to use here? Well, x plus 2, obviously. Now, what are we going to raise this x plus 2 to get a reasonable kind of answer? Well, if we were to take out the negative 2/5, what would I get? Well, I'd end up with a 1 here, and we're going to be subtracting off. Now, how do I get a 3/5 when I have a negative 2/5? Well, that would be a fifth, wouldn't it? To the power of 1, in fact. Because negative 2/5 plus 1 would be positive 3/5. So we'd end up with x plus 2 to the negative 2/5 by 1 subtract x subtract 2, which of course is x plus 2 to the negative 2/5 by negative 1 subtract x. Alright, and that would be my result.